I can go.
starting.
I can go
There we
first.
go. All right, so
Yeah.
I'll just kind of catch up now that we're recording. Um, we're gonna have Daniel Spofford. He's on here. He's gonna talk to us about some Bluetooth stuff, and then we'll get some more nerves insight working with hardware and with SPI and I2C for Manuel, and then whatever else other junk comes up. Um, if if any of you are new, if you want to come on, say a bit, say your name, that would be great. And then once we get through all that, we'll just go ahead and start with Daniel. And I guess I'll kick it off for those who may not know. My name is John Karstens. I work for SmartRent. I have been doing lots of fun stuff with nerves lately, so hopefully get to keep continuing that down the path of hardware. And yeah, I'm just a general hobbyist enthusiast. So anybody else want to go next for us?
Yeah, I'll go ahead and introduce myself.
Okay.
So I'm Andrew Lewin. I am working for Savvy right now. I just barely heard about nerves for the first time on Friday. So I'm just barely getting started with all of this. Figured I'd join the meetup and, start getting involved here. Nerves is sounding like it's going to be a pretty big thing for us at Savvy. So just jumping in head first to it all.
Cool. My name is Aaron Renner. I work for Active Prospect. I don't get to do nerves at work, but definitely I'm an enthusiast in it, and I'm happy to be here.
I'm Frank Kumro, and I also work at Active Prospect. Been doing nerves for a little over a year now. Latest thing I've done, it's more hobbyist stuff, is GitLab CI CD Lite. And I also talked at ElixirConf about nerves.
All right, cool. Well, let's just let Daniel kick it off and and get us going. What do you got for us?
Sure. I don't have a demo or presentation, so sorry, no PowerPoint. But I was just going to introduce myself, kind of give the use case that drove myself and the company I work for to do Bluetooth stuff here, and just call out some things about Herald. So happy to be here. My name is Daniel Spofford. I work for a software consultancy called Very. You can find us at verypossible.com. A lot easier to type the URL than it is to search Very. Well aware of that joke. I've been doing Elixir for a while now, I think maybe 2014. Happened to work at a company that did phone stuff, and Erlang led into Elixir pretty quick. At Very, we solve all sorts of client problems, but lately we've been leaning into the IoT space. We had a sort of R&D client engagement where they wanted to have a device that could detect smaller devices around it and have them provide meta information like identification or the battery level that was left on the battery that they were attached to, stuff like that. We've used nerves in the past, and Bluetooth sounded about right, so we went down a path of nerves and Bluetooth. There isn't really a standard Bluetooth solution in that space, as some of you may have found. We didn't really want to go the BlueZ route because of friction to use it, and it was like a little bit bloating in the firmware, and we kind of saw an opportunity to make a library here, so enter Herald. Herald is an Elixir Bluetooth host library. It's meant to be a singular host for a particular controller, meaning you can expect the unexpected if you try to leverage Herald alongside another Bluetooth stack like BlueZ. they'll probably conflict in the commands they're sending, and you'll see unexpected results. Because this was happening in the context of a client project, the path of least resistance for us was leveraging the host controller interface, HCI, via UART for Bluetooth. We originally got this running on a Raspberry Pi 3B, and then we sort of transitioned into a BeagleBone Black wireless. The driving use case here, the only use case really for us, was to be able to scan BLE devices, in particular iBeacons, and later not iBeacons, advertising using service data 32, so we could stuff in our own data into what was being advertised. We didn't want to connect to anything. We just needed to see the presence of these devices. So that's kind of what drove us into developing this. It was very point A to point B type of thing. And then we, we're talking with Frank and Justin and people, and there's interest here. So we decided to open source it, and we're kind of trying to make that transition now. So the BLE scan is really the extent of the convenient high-level functionality there. I can speak to what else is in there. There's lots of tests. We're doing property testing with stream data. We're targeting the symmetric serialization of when these binaries come over and we deserialize those, you should be able to reserialize that and get the same value that you were given originally. And that's a novel way to do testing in a space like this. So that's cool. You get some neat gimmies there. In order to do that, you have to have generators for this type of data. So there's a lot of utility to generate arbitrary Bluetooth data structures that can be leveraged in neat ways outside of this library. There's a lot of reference documentation anytime where the spec maps to the code really well. There is usually snippets of documentation and where that is, which we have found to be really helpful extending this because the Bluetooth spec is enormous if you ever download that PDF. So that's helpful. The core framework for sending commands and receiving events to a Bluetooth controller is there. So while scanning is the only convenient thing to do right now, it's very trivial to use these building blocks and send arbitrary commands and parse arbitrary events coming out. I could probably speak I won't right now unless someone wants me to, but there's a lot to say about the BeagleBone Black wireless and the TI Y-Link chip it's using, and some novel things that we had to do when trying to stand up Bluetooth on the BeagleBone versus the Raspberry Pi. Some very time-consuming problems there that I could probably talk to someone who's interested in about that. So notable. Go ahead.
Sorry, was that mostly a decision, like you're saying, just for ease of getting up and running to switch to the BeagleBone Black versus the Raspberry Pi, or is that just where your hardware needs drifted?
The fastest thing for us to start doing nervesy stuff on was a Raspberry Pi. So start doing stuff on a Raspberry Pi, get business logic on the device happening as soon as possible. And then meanwhile, there is hardware and other decisions happening, and that guided us towards basing it off of a Beagle versus a Raspberry Pi, because that would be closer to what the custom production board that we produce will be. So the transition to a Beagle was not because it was easier for any sort of Bluetooth reason. It was actually significantly harder on the BeagleBone. There was a lot of crazy stuff like that the chip there, the kernel driver, when it stands it up normally and you go like a BlueZ path, TI has these .bts files that are kind of like a proprietary file that has commands that need to be supplied to the chip as it's booting in order for it to work properly. And the driver usually handles that for you. But if you go the route that we're doing and you circumvent that driver, that's not happening. And the chip is it's unresponsive to anything you send over UART. Figuring that out, that was the issue, it was not trivial for me. Like I said, I'm leaning into this embedded space now. So there's a lot of stuff that I stare at for days and then I figure out, and it's easy going forward. But yeah, as we're probably aware, there's less, or I'm very aware, coming from a sort of like cloud and web and backend services type of space and entering into here, the level of documentation and the ease at which you can obtain the answer to something is significantly harder in this space, I have found. To make stuff like this really useful, where someone else can cut their fingers on the corners and then you just get the answer. But I don't want to ramble. I mean, I can continue rambling needlessly, but I'm happy to, people have questions about the use case or about Bluetooth or stuff
Yeah,
like that.
that was going to be my next. So this is a lot more lightweight than Blue Z, which
Mhm.
is everybody wanted. What are some use cases that you're finding it really good for, and maybe some that they're not, it's not good for right now, and then past that, what are some future goals or something you'd like to see it be used in or developed around or even built out more?
Yeah, what it's capable of right now is, like, convenient is an important word. What it's capable of doing conveniently right now is very little. Like I said, scanning. But you're able to send any of the commands if you're willing to figure out what the binary looks like. Um, I think we have in mind the scope of this being certainly anything in like the standard LE commands. If you pop open the spec and anything in there, we hope to support that or make it convenient to add support for that. Things in the spec are certainly open game for Herald, but anything that you can ask these chips to do, I guess, Herald would be a good, we want Herald to be the thing that you use to control Bluetooth chips in the nerve space. So eventually, if it's able to encompass that functionality, then it would be a good use case for Herald. That's kind of a cop-out answer, but that's the mission statement, right? Support all the things. PR is welcome.
So my knowledge of Bluetooth probably isn't much higher than my parents. You know, what they know about Bluetooth in their phones. But there was one thing that a project that I was interested in sometime in the future looking into, and that's like presence, like knowing whether I'm in the office or if I'm, you know, in the garage. And so I was wondering, the way that I was thinking about doing that was something along the lines. I think what you're talking about with the scanning, is that right up the alley of Herald?
That's a huge use case of a lot of Bluetooth things. A really popular one is like an iBeacon, but any sort of, it's a very common use case to have something that requires very little energy and you just leave it in a place and it broadcasts some identifier and you can use that to make decisions. Whether that means you're in a certain room or whatever you want to surmise from that, you know, you can. And that is exactly, in a sense, what we're doing right now with Herald in production. We're scanning for the presence of things.
Okay. Does our phones, like a typical Android or iPhone, do you have to like turn it in, like have it scan for it to be showing up, or is it are our phones already like something for you to query without having to do anything?
Well, you can, so whether something else could see your phone would be dictated by whether or not you have Bluetooth configured or enabled. Like you can tell your phone to not advertise, you know, and then it wouldn't show up. So the user of that phone would have control over whether they're visible or not. But with these, like the iBeacons, for example, usually those things, like it's obviously that's its own physical device that just sits somewhere and emits.
Okay.
It's usually always on. There's a company, Williot, I think it is, or Will IoT. I don't know how clever they're trying to be, but they're producing a tag that does basically what an iBeacon does, but it's disposable. Like they're so cheap, and it's really cool actually. They like leverage other radio waves in the air to generate power, so that they have enough power to emit their radio frequency. That's neat. Probably overkill, but
That is very interesting. Have any of you messed with SDR, software defined radio, at all? Okay, well, if you ever get one, if you don't have it, you can get one for like $20, $25. Definitely a tool worth having. But anyway, I bring that up because if you ever plug it in and you just start absorbing frequencies around you, it's just amazing how much radio traffic there is. And so I'm in Idaho. It's pretty rural, and there's just so much chatter. So that's really neat if they can figure out how to somehow capture radio traffic, radio signals to help charge and power it, because it's freaking everywhere.
It's a really neat idea. It's like something that you think about and you're like, that's dumb, that wouldn't work. That seems like cheating, but it turns out it works, and they're probably going to be very wealthy.
Yeah. You're almost really skeptical of it. Like
it was neat.
Too good to be true.
Even the first time that I scanned, like I live in an apartment building, with the first time I scanned with Harold and had it work, the amount of results I got back was staggering. All the tile devices, and I don't know, it's like 100+ things. It is interesting.
So Harold is just kind of listening in for all of these devices, like these iBeacons you were talking about. The iBeacon or these other devices are just broadcasting that they're here, but it's the app, or it's the device with Harold on it that's actually making use of any of that. It's information coming from the beacon device to the other device, not the other way around. We're not talking to the beacon's talking to us.
Correct. Yeah.
Cool.
Harold itself is meant to be on a device. So when I say it's a Elixir host library, contrast that with being Bluetooth host versus like a Bluetooth controller, where a Bluetooth controller is the actual thing with a radio that knows how to accept commands like scan at this strength or something like that. It understands that and will do that to the radio. We are a piece removed from that. We are speaking with that over HCI, the host controller interface. And that's the thing that we're giving these binary commands to, and then it knows how to ferry that along to the controller. So that's all happening on one device, and it can advertise itself. It can scan and listen for other things. It could connect to other things, be connected to all the things that, with Bluetooth, it's capable of doing. In our particular use case, yes, there are things that are just always emitting, and we're controlling something and we're asking it to scan, look for those things.
Got it. That's cool.
An interesting anomaly we had. Bluetooth is neat. Working with physical things is neat. There's one of these things that scans, and we were looking to do accuracy tests. We were having it scan like every 5 minutes, and are you reporting the same thing over and over and over again? And at like 1 a.m. In this warehouse, there was a drop off of like 45 of the things we were scanning. We were like, that's significant. Like it's consistent for 20 hours, and then all of a sudden. And it turns out that between this device that's scanning and whatever number it was that dropped off, a truck had pulled into the warehouse and parked for like 10 minutes. And that was when one of the scans happened. So Bluetooth doesn't do well going through metal stuff. So not your normal bugs, I guess.
Have you done any range testing to find some limits? See if there's variation in the library versus hardware versus yada yada.
Yeah, you can. My understanding of it is that there is play. You can expend more energy to get a further range, or expend less energy and not have quite as much distance. The number I hear thrown out for a high end of Bluetooth is like 100 feet. I wouldn't feel comfortable with the use case that I have, for example, being like, yeah, it's totally fine to have one of those things 100 feet away and expect us to see it with 100% accuracy. It gets iffy at that range. We have found that for our use case, where we're trying to like consistently identify things with a scan, that about 50 feet is like the safe distance you want to be. But we haven't had a more specific need to do like we don't do ranging, for example. When we're seeing these devices, we don't care how far away they are. We just care about a binary: are you there or not?
Are you guys looking at just like one, like from one I guess, sensor, or are you triangulating between multiples to give an idea of where they are?
Yeah, to tread the line of context carefully here, it's usually one device that's scanning, and many devices around it that we're looking to see. You can think of the use case here being like like points of sale, distributor locations. The problem statement here is like a supply chain problem where you have a company that's selling stuff on consignment racks at stores that it can't dictate the point of sale software to. So they have trouble having up-to-date information about what is in stock. So their solution is such that they have these devices on each of these non-trivial things that they're selling. And when they get sold, these devices get plucked off, and that kills its advertising. It stops advertising itself, and it no longer shows up to this thing that's scanning. So you can have a more real-time idea of what is there or not. Right now, they have like people physically going and checking inventory, and it makes the trucks that they fill inaccurate with what they're bringing to restock. So, supply chain logistics buzzword. I would love to do stuff. Someone reached out to me about like connecting devices and like having, like, I haven't explored that space at all. Like, what does it take to use Herald to ask some Bluetooth enabled device to connect to another device or stream audio or stuff like that? That's well within what I would like the purview of Herald to be capable of allowing, but I haven't touched it at all. But that's really interesting.
Those are interesting protocols. I've dug into those a little bit before. They are interesting protocols and problems to solve. So I have a question that many other people may have. What's in the name Herald? What was the inspiration behind this library choice?
A coworker suggested it. I can't take credit for that, though I like to think that I thought of it on my own too. The original naming of Bluetooth, I would butcher it trying to accurately tell you, but if you look at like the Wikipedia page for how Bluetooth itself was named, there's some dude was reading a book about Vikings, and there's like a King Harold, and his last name was like Blue, and somebody else had Tooth, and he chose Bluetooth because he chose Bluetooth, and there's a king named Harold in the story somewhere, and that's where Harold came from. And it has a neat sort of double meaning too, like Herald as in a messenger, and we're schlepping messages around. So
that makes total sense. In fact, the chief marketing officer at my last job was one of those guys helping design or helping market and make this Bluetooth standard. And now I remember him talking about, I used to remember the guy's name's King Harold.
Yeah, the logo for Bluetooth is like Viking sigils overlaid. There's like a whole
it's like a B and H, right? Something like that. Ah, there we go. That makes sense. And that makes sense why I can never find it Googling, because I never spell it with an A. I always spell it with an O.
Yeah, graphics and marketing are hard, man. I tried to come up with a logo like shifting around the sigils from Bluetooth and having it be something, and then I was like, I should close Photoshop right now. I don't know what I'm doing.
Yeah, my go-to is just like paste it on something else. Put a Nerves logo and just put the Bluetooth on top of it.
What can I superimpose on this?
It's good enough. Cool. I think that's all the questions I got for it. Anybody else have any other last questions before we move on?
I don't.
All right. Well, thanks, Daniel. It's good to know. This is a library that I was really excited to see come up. In fact, in working with Frank a few times, I had Bluetooth questions, and he was like, "Hold on, I need to talk to these guys. Hold on, I need to talk to them. I really just want them to open source this stuff." So to finally see it come was fun.
Yeah.
So yeah, thanks for coming on, giving a little more insight on that, and hopefully we can start playing with it soon.
Yeah, if anybody, my parting words would be, if anybody is curious to use it or play around with it, please do. I apologize for everything that you're going to see and experience as part of that. But if you complain about it or make an issue or say something in Nerves Bluetooth, that's super helpful. It's a bandwidth issue right now of not having enough time. So any sort of like little thing like that goes a long way. But yeah, thanks guys for listening.
Thank you for showing it to us.
All right, well, it's on to you.
All right. Yeah, so I'm Manuel. I work for a company called ChapterSpot. I pretty much do DevOps 50% of the time, and then I get to play in Elixir working on Phoenix apps. But at home, I like to dabble with Nerves. And so Michael asked me to show something that I had been working on. So let me, I'm starting to talk. Let me go ahead and make sure everybody knows that I'm on air. All right, so let me share my screen if I can. All right. All right, so this is going to be light on the technical aspects of SPI in I2C. I think I might have gotten Michael a little excited about it, but pretty much. Let me see if I can do this at the same time. Cool. So I had a project that kind of like came to me. I was wanting to, utilize these little Pi hats that I did the Nerves training at Lone Star Elixir, or the Nerves Hub training, like where we got to play with this, and I thought they were really cool, and I wanted to find a reason to use them, and also kind of had an idea come up that seemed perfect for it. And what it is, both me and my wife work from home, and it's great, 95% of the time. But that 5% of the time when I'm working or like in a meeting, sometimes she'll be out in her shop, just texting away, like letting me know something is broken or something's going on, and I wanted a way to tell her, like, hey, I'm in a meeting, chill with the text messages. So what I came up with was, wanting to do like a on-air light, and so this is controlled via a Raspberry Pi Zero W, and then I also have another device in my office where I can kind of set, whether or not it's do not disturb. Additionally, this syncs up with my work's Slack, and so I can turn off the do not disturb, and within a couple seconds, maybe not. Give me a sec. Yeah. All right. So the light is supposed to sync to the do not disturb of my company's Slack. But anyway, so where this kind of started was, this is the Adafruit Pi OLED Pi hat that we used at the training. And I had found this other hat that I thought was going to be essentially the same for cheaper, directly from Amazon. And so I had ordered it and was severely disappointed whenever I got it, and it I started to realize that this just isn't the same thing. And so what ended up happening is I had to develop my a OLED driver for this Pi hat. And so let's see. Sorry, I was on the right one. All right, so I did develop a driver, and part of this, like, so my day to day, I'm not working in hardware. I'm not working with SPI or any of this. So this is all like a really foreign territory for me. But I utilized circuits, and I started to follow the implementation from a Python library called Luma. And so doing kind of a deep dive here and trying to dissect what it is that they do and how to actually communicate over SPI. It almost became like a one-for-one, like read what they're doing and then implement it in Elixir. So it really isn't something that I'm not like super proud about. I'm just kind of did what they did, but I was there was a lot of satisfaction going from something. I was having issues here, like where it should be can chat, the display, the actual ordering of the pixels wasn't straightforward. Like it wasn't left to right, or even snaking. There was like bars that went through, so it was a little bit of trial and error. But once I figured that out, I was able to actually get the OLED to work. So so there's this SH1106, which is the display, and this library that I created. Now, how all this works is I have a server that's running, and it's polling the Slack API to get changes in the do not disturb and the statuses. It subscribes to MQTT topic that is coming from the little Pi in my office. And I realized after typing this out that that's a lie. I'm currently using channels, but the intention is for it to be using MQTT. But it does publish over MQTT to my on-air light to tell it to turn on, and then it also takes responses, or takes the messages from this other device and then actually executes the Slack API calls to trigger it. So let's see. All right. So now it is actually sorry, my cat actually disconnected the camera. Sorry about that. All right. So yeah, so that's the server that is polling the Slack API, and then also listening to this, which is the scenic. Let me go ahead and toss this over here. Sorry. All right, so this is the scenic application that is running on the Pi hat that allows me to have some predefined status and emoji and duration for setting my statuses and the do not disturb. And this is the current status. So like in my Slack, I'm not do not disturb. So D, no. Present, I am, my little light is on in Slack. And then I don't have a status. And so if I set that, you notice do not disturb is now on, the light is on. And if we roll back over here, do not disturb meeting Slack. This is what I was using on my little Pi hat. But so the other thing that I worked with was the Scenic library, and then having that work with the OLED bonnet and the display. And so this currently connects to the server using the Phoenix channels, and it through that it sets the Slack and do not disturb stuff. So the other thing that, sorry for switching all around. The other kind of interesting thing that I wanted to do was a future project, which is wanting to have lights underneath my my counters inside the kitchen. And so part of what's running or the Nerves application that's running controlling the lights, it's powered by Greg's Blink chain, but it exposes JSON API over MQTT for controlling the LEDs. And the purpose of this was to get it to interface with Home Assistant, which is something that I use inside my house for controlling all of my IoT devices. So one thing about this is I'm starting to play with the Gen State machine for some future work for having predefined effects like strobing and rainbows. But just to show you this, so I do have, sorry, lights, there we go. And I think, there we go. All right, so within Home Assistant, I can just sit here and, which is pretty much the only thing that I've done since I've got this all working, is sit here and play with the color wheel, and then adjust brightness. But with Home Assistant, and also use Node-RED for building out the automations. I'm able to do things like on motion inside the living room, turn on this Nerves powered LED strip. So I think that's all I had. Yeah. So yeah.
So you have a little Nerves device in that on-air enclosure with just some NeoPixels, and you're using Blink chain to control.
Yeah.
Okay.
So have a little Raspberry Pi, and then the NeoPixels, and there's the server that's running, and then this little guy, which would be on my desk like here, so that I can quickly be like, hey, I'm on a Pomodoro session, so set Slack to do not disturb, tell the wife do not disturb, and this would ideally be inside the garage, so that when she goes to text, she's like, shouldn't do that right now.
That's cool. So Home Assistant, I just learned about this weekend, but it's essentially an open source platform for trying to gather IoT things, right?
Yeah. I love Home Assistant, but I'm my next big project that I want to do is so Home Assistant, it's written in Python. I've had the pleasure of taking a look at the source code, and it's like, this is nice that you guys did this, but the whole kind of event sourcing and event driven thing, like this screams Elixir. And so I'd like to take a stab at doing something like this, more for personally, but to take over everything that I'm doing in Home Assistant on a embedded Nerves device. But yeah, it's I can kind of show you some of what I've got. So I have these Z-Wave kind of all-in-one motion and motion, luminance, temperature, humidity sensors kind of sprung around. So these are all like ranging from hue lights. Some of these are hue lights to most of these are Z-Wave light switches, and then Z-Wave plugs inside here. There's kind of if there's an IoT device that you have, there's some type of integration that's been built into Home Assistant for controlling it.
So that's what you were saying that you did, is you basically made your little nurse device be able to integrate with that through their JSON API or their MQTT brokerage?
Yeah, so they have a slew of components that you can kind of like essentially drag and drop. It's all done through YAML configuration files. And so they've defined a API for interacting with a light through MQTT. And so what I have created is a library that wraps Blink Chain and listens on a MQTT topic for those commands, and then also publishes its current state on another topic. And so by writing this library, it's now it was a matter of a couple of lines of YAML configuration for me to be able to come in here and actually muck with it.
It's pretty cool. What I have found is I can very quickly make Nerves do what I want to and control stuff around me, but I am not a designer, nor am I a front-end engineer. So 98% of the time, the interface is whatever bootstrap button I can coerce to stay on the page, and CLI.
Right.
It would be nice to have some sort of plug and play front end.
Yeah. So, one of the things that, like I had this idea, I was like, all right, yeah, the Nerves and Elixir, this seems like the perfect tool to solve this, this problem. Like it seems better than Python for having the concurrency baked in, because like that was, the first thing that I saw was like they were monkey patching Python to deal with there was like a comments like, yeah, we monkey patched this part of the language because we were having race conditions that we just couldn't figure out. I was like, this screams, the actor model, the not having the GIL and doing threading and everything that they're doing to make Python work. But where I kind of quickly was, I guess, like set back on that, thinking that was going to be an easy task, was opening up their requirements file or requirements.txt and realizing that it's 2,000 lines long of all of these Python libraries that do things that, like, oh shit, we don't have in the Elixir ecosystem something to interface with the Trod Free, which I believe is IKEA's IoT stuff, right? So this kind of pumped the brakes on my excitement that, like, oh, I could easily replace Home Assistant with something that I did in Elixir and Nerves. But one thing that I was starting to look into was ports, using ports to then execute out to a Python shell, like an interactive Python shell that, so instead of having to write my own, Trodfee or whatever SDK in Elixir, like use the Python one, but access it via a port into Elixir. So something that I'm back to being excited about, and hope to start tackling this soon.
When you have a Home Assistant and you have some device configured with it, is it possible to control that device externally through an API that Home Assistant exposes? Does that make sense? So if you have a light set up with Home Assistant, could you have some other application that hits an API to turn that light on and off?
Yes. Yep.
Does that come into play with the problem you were describing here at all, where, is there something where you could like configure it with Python over here, but you have like coordinating Elixir software over here that's using APIs? Is that interesting at all?
It's not something that I explicitly thought of, no. But I think for me, I would still be most interested in the underlying architecture of it being done in Elixir. It's really, if I could keep the Python at the edge, being the thing that interfaces with the SDK that's out there, I would feel better about that. But that's really just for stroking my own ego, I guess.
The interesting parts are interesting. That's where you want to stay. I get it.
Yeah. I am using the API for, actually, I forgot, my first Nerves device is sitting in the garage. And it's just a Raspberry Pi Zero with a button on it. And you press the button and it calls out to the Home Assistant API to turn on my wife's laser cutter out there.
Cool. Well, anybody else have any other questions around this, or? No,
So
I think we're good.
I got a question quick. So you mentioned MQTT a few times, and I've seen that a little bit. But is that like, does the Nerves device open up like a persistent connection to be controlled, or how? Can you explain how that works?
Sure. So MQTT is it's like RabbitMQ, but designed for Internet of Things, right? Like it's designed for these embedded systems. It's a real lightweight pub/sub protocol. So there's topics, and publishers publish to them, and consumers consume from those topics. The library that I'm using is this Tortoise. And so I'm, pretty much so let's see. So for the light, you define a handler. So you use Tortoise handler, and you handle messages. So right now, I'm for the light. I started off with kind of like playing directly with Blink Chain, and so on the topic that I subscribe to, if you send it just a regular HTML or CSS hex color, it just fills in all of the lights that color, and then after that, I started to play with the JSON, and so this actually takes the JSON object, but all that you do is define a handler, and then you can publish back. This is publishing the current state back to MQTT.
Cool. Thank you.
Mm-hmm.
So do you have to manage your own message broker, your own MQTT broker, or is that what Home Assistant does?
Yes, double yes. So there, I currently manage my own, but it's literally just a Docker container. Very minimal actual managing of it. But there, I believe AWS's IoT core or whatever, like that, it's essentially a managed MQTT service. That if you didn't want to do that, you can.
We're using AWS IoT Core with the device that we're working with.
And is that MQTT under the hood?
Yeah.
Okay.
Yeah, I mean, AWS IoT Core is a sticker label over MQTT broker. That's what it is. They have there's other stuff in there like device management and things that tie it into the rest of AWS's IoT offerings, but that service in particular, yeah. They support custom CAs, John, and we use Nerves Hub and AWS IoT Core. Same CA.
Ta-da.
It just works.
Yeah. Story of my life. Well, awesome. Thanks for that.
Mm-hmm.
Are there any other questions or topics you guys wanted to discuss a little bit? We're kind of at our hour mark, so we can wind down if we want, or if you got more you want to chat about, we can open it up, see where it goes.
I have a question for Daniel. So given the fact that I told you I know very little beyond the name Bluetooth, like how quickly do you think somebody like me could import define Herald as a dependency and like start just scanning and getting a list of Bluetooth devices around my BeagleBone Black?
Yeah. So the answer to that question should be like 2 minutes. It should be very easy, and there is getting started docs that suggest that and get you 90% of the way there. But there is still, like, depending on which particular Raspberry Pi you have, there might be something that I haven't tested with. The answer should be very easy to do, but I would love for you to try that and message me when you run into an issue.
Cool. Which Raspberry Pis have you tested on?
The Raspberry Pi 3B v1.2 is what I got on my desk.
Gotcha.
And I think that the other ones will work as well, given like a 5-minute back and forth with me.
Okay.
I think that the problem is not significant, but when I started doing any of this Bluetooth stuff, I was in a very similar boat to you. I was like, yeah, Bluetooth. I have headphones that do that. That's cool.
Right.
And that's I think I mentioned a little bit why, like, calling out spots in Herald where I like quote the spec and link to a particular part in it, because it's like a sea of 400 pages and it's super overwhelming, and you would never make progress unless you know where to focus your attention. And that's what we're trying to do in those getting started docs, is so that you can just like, I have a device, I like nerves, let me turn it on and see things around me.
Awesome.
Where exactly are those getting started docs? I'm looking at the hex docs.
Yeah,
and I
no,
see lots of
the classic, I merged it into master but didn't do a hex release problem. So
yeah.
master on GitHub will have like a guides, like a top level guides folder, I think. I believe that's where it is. But yeah, if I sounds like I need to do a hex release so that you can get those where you would expect them to be, the
There it
appropriate
is.
place.
Boom. I'll drop it in the channel.
And you can, yeah, if you look at it, it's very tiny. Like on a Raspberry Pi, you should be able to include the dependency, drop a tuple into like a supervision child definition, and then call scan when you're on your device. Like it should be that easy, but there's other things.
And forgive me, like for my phone, like right now I have Bluetooth on.
Mhm.
Would that show up in there, or
I
do I
don't.
need to explicitly say scan on my phone?
Well, if you have a Pi device and you're looking to see your phone,
Mhm.
I don't know, maybe someone else here has this knowledge. I don't believe that phones, even if you have Bluetooth on, are just advertising themselves, just like existing. You know what I mean? There's usually intent behind it. It's like, I'm about to pair with something, so you press a button and that indicates to the phone, hey, advertise yourself in this way. That's usually how those things happen. So I don't think if you like just had your phone, you would be able to see it, but I could be wrong there.
I'm pretty sure you're right about that.
Yeah. I mean, if you have, you'd be hard pressed to find a home these days that doesn't have something that would show up on a Bluetooth scan. If you have kids with a PlayStation, their controllers will. If you have, like any number of things.
Yeah, it sounds like what I would need to do is get some of those beacons. Like the thing that I'm curious about is like, yeah, I have my phone all the time, and so I would love to be able to set up like a couple of,
and they're
Raspberry
cheap
Pi
too.
phones.
They're really cheap. We had used there's a device called a HM10, I believe, and it's like just a little iBeacon device. It just shows up and advertises to Apple's spec for what an iBeacon should be, and I think it's like a few dollars, so they're pretty accessible.
Right.
Is there any of this Bluetooth library that's usable on like a straight up Linux desktop machine or Mac or anything that would work outside of the Raspberry Pi environment?
Yeah, so the thinking about that is interesting. At what point can I actually use Herald to do something is, as long as the way Herald communicates right now is point me at some, dev UART1 device file, and I will be able to, as long as the controller, the hardware that has the radio is listening, I will be able to control it and tell it to do things. So it's possible to be in that state on like a laptop or any given Linux machine. The issue is usually that there are other things competing with you to control that Bluetooth. So for example, on like a Mac, you'd probably, I haven't really tested it much, but I imagine you would have a hard time leveraging Herald to do Bluetooth things on a laptop like a Mac, because the Mac is going to be talking to that Bluetooth chip itself. And you'd be competing with what you're trying to get it to do, I would imagine. And I don't know if they even expose a UART interface to it, but I guess the answer to your question is if you are on any machine that exposes the HCI interface via UART, then Herald would be able to be used in that setting.
Okay.
Does Herald have a way? So in like circuits UART, you can do an enumeration to see what sort of devices and maybe even a Bluetooth controls you have. Does Herald have the same sort of function where you can enumerate to try to discover?
Not really. I mean, no, not really. No is the answer. You would be able to do a circuits UART enumerate, and potentially some subset of those results would be, a target for Herald for Bluetooth. But you would have to. I don't know I don't know enough about like Linux and stuff like that, and these chips if there is some standardization in, oh geez, knocked over a glass, in which path they open up on, such that you could deterministically enumerate them and find them. I don't know that that's the case. I would suspect it's not. But you could I know it's common with those enumerate things to enumerate them and then throw commands at them and look for a good response back and use that as your method. You could certainly do something like that, but that's not built into Herald yet, no. As part of the configuration, when you're defining a child spec to manage Herald, part of that is pointing it at a device path that it will speak UART at.
Cool. Sorry, I'm distracted now that I found the getting started stuff.
There's also like a shoddy wiki page that I just like brain dumped for 2 minutes one day that I probably shouldn't even mention out loud, but it's too late now. If you want to click wiki, there's something there.
Whoa, look at all that.
Whoa.
There's even images down here.
Somebody downloaded OmniGraffle. That's what that page says.
Cool. Alrighty. Any other last minute comments, questions? Fun stuff. Oh, I heard a.
Did you hear my intake of breath? You're so perceptive, John. I've been, with client work, I've been interested in this might be too long of a conversation, so we can just hop out of it if that's the case, but I've been interested in the area of IoT that is, you're hitting production, you're hitting provisioning, you have devices that are about to be in the field, they wanna communicate, let's say with AWS IoT Core, so there's going to be some MQTT going on, or maybe there's some Nerves Hub going on. The key point being, we need a unique certificate on this device. And the process of manufacturing and provisioning these devices and having at the manufacturer, that be the point where a certificate is either claimed or created by your trusted CA and put onto that device, that's a very interesting area to me. And I don't think there are best practices and there's like common things that you can follow and do to do it correctly. But there isn't, whereas there are other areas in this space where it's like, this is the answer, this is what you do. That it doesn't seem like there is something for that space, and people are kind of just winging it every time, kind of a pre-Nerves Hub thing, right? Like, how do we do over-the-air deploys in a correct, repeatable way and not have every company reinvent this? I feel a similar tension in the provisioning process. Do you generate a token for that manufacturer that they can use to hit an endpoint that provides a certificate? Do you give them a bundle of pre-signed certificates? I don't know. If anybody had thoughts there, I would be curious to hear that. But
so I guess I could talk on how we do it, and some of the design decisions that were there, which is basically, this is all Frank Hunless design and brainchild and how it's happening. But we use the ATEC 508A or 608A, which are cryptographic chips, which like you're saying, it could be provisioned, but they have one-time write bytes on it where we actually write.
Is that the module that's in the nerves key?
Yeah, so that's
Okay.
so that's what's in the nerves key. So the provisioning happens like this. Is I'm like 98% confident this is what we do, but we have our own CA and we provide whatever production CA signing certificate we need for these devices to the manufacturer, and that gets provisioned and written to that one-time slot on these cores or on these little chips. But then when we get the chips, we finish a provisioning process by actually using that private certificate, that private CA, to generate a unique certificate for the device that then gets written into
clever
alongside of it. And so then
common manufacturing cert, and then
right,
get to a safe place, get a unique cert. That's cool.
right. And so then we send that signing certificate or that certificate authority and the signing certificate in the request to Nerves Hub. And that's how we compare the CA and the signed device certificate and make sure that all is well on the client side. But then for other connections, we actually will use server-side SSL as well, where we'll compare with the counterpart certificate on the Nerves key. So kind of like both areas of attack.
Yeah. Yeah. Interesting. It's like how much work and how much trust you want to impose on a manufacturer. Having a common one and then like having them be unique later. That's cool.
Yeah, kind of like going the CA route, just make a certificate authority, which all of them can trust, but then they have to make their own unique. And you still have to validate that certificate authority on communication.
It depends on like the use case too, because our these devices would get like they have to be deployed into the field. Like so they're going to interact with a human at some point post manufacturing anyway. But is it a use case where that person is qualified to, like, could you delay the cert until that point, I guess is what I'm getting at. You know, could you not even bother with it until they try to deploy it and then some tech does something, but then that imposes tension at that point of the process. And yeah.
Yeah, but and then what's the error fault there, right? So with our hubs that we actually make for SmartRent, this chip is actually embedded in the hub. So it's not just like the Nerves key that you can solder on and solder off. So if we get to attack and they fat finger the identifier and the provisioning of it, you know, and now that whole board's fried. And these things are like teeny tiny. It's, I mean, nobody wants to save cost and try to solder it off and solder it back on. I don't even know if you can. You can even get a tip that small outside of the industrial area. So I think that's why we go the route of having the manufacturer provision versus like, let's put it in the hands of the tech and hope that all is well. We're not out X number of dollars.
I was looking into the Nerves key the other day. This is the last thing I'll say. But it's an interesting problem too if you think about long-lived devices. I feel like that is something much like security in the IoT space that often gets glossed over, but certificates expire. Device certificates expire and CAs expire. And the solution to this is usually expires in 2050. And then you're good. But if you think about people who maybe didn't think about that when they generate a CA, or maybe when they're generating these device certs, maybe, you know, it's only 2-3 years, and maybe you're lucky enough to where your device lasts that long. Cycling certs, I feel like, is another area that is unexplored, scary, sketchy. You know, how do you juggle that cert, especially when you're trying to leverage hardware like you are with a Nerves key, where I believe that can support 2 certs for that reason, that you could like write. It is write once, but there's like 2 slots, I think, something.
Yeah.
But
so
yeah,
there's technically 4. So there's one for the one-time write CA, one for the runtime private, and then
that's right. Same
the
key.
counterpart
new
is
cert.
one for an auxiliary CA and one for an auxiliary private, and that's you can wipe that out and put it back in as much as you want.
Okay, that's cool. That's a just like just-in-time provisioning. That's something that you want to get right, like cycling a device cert, pushing it out, making sure that you don't toss the old one before the new one is valid, and interesting problems in this space.
Yeah, and in some areas, I also think about how secure do I need my device to be. If my device has a single point of communication to just tell it to do a binary action, for going through the motions, I don't mind doing a simple encryption, just storing the cert with it, and I don't need some cryptographic chip. I mean, heck, I'm usually good with the Phoenix channel and a token that I can expire, re-provision the device with.
Yeah, many use cases don't necessitate the the level of care.
Cool. Well, how about, are there any topics or projects that you guys want to see for the next time, or anybody that has something cool they've been working on that they might want to present or discuss? After talking with Mike, I think we're going to try to keep it to a more organized state. And so about a month from now, we'll keep it to this last or sit next to last Wednesday of the month. That's what we'll try to shoot for. But I think keeping it how we're doing, that's kind of the goal, but we'll blast out and see if a specific date works better for people as it comes closer. We'll go through. But anybody else want to come in, tell us a bit, talk about a project, something they're working on? Dang. Well, we'll have to ask again later. So it's not always the same stuff. Well, cool. Thanks for coming on, everyone. If you've got any other stuff, definitely just put it in Slack. We can all chat and discuss more, work on other projects. I'm usually pretty available to answer questions if you got cool things you're trying to work on and want to get through. And lately, I'm almost exclusively working in Nerves and Nerves Hub. So especially if you have questions around there, I'm happy to help get things going, working with it. I have lots of opinions. And I guess we're good at that. So we'll just see everyone next time.
Thanks for organizing, man. Appreciate it. It was good talking to everybody.
Thank you, Daniel.
Yeah. Thank you. Thanks for the invite.
That's it.
Yeah, thanks, Eric. See ya.